So now you can see the slide. Okay. So today I will introduce about the three-dimensional tolerance stick-up from the perspectives of 5W. So you will know that who use the three-dimensional tolerance analysis tool to do the stick-up, and what is the three-dimensional TA, and also why we need to use 3D but not 1D for a stick-up. So, and also when you can use these tools to do the some activities that related to the 3D TA. And also in the last, I will show you some cases to show you that where you can use the 3D TA in different industrial fields. Okay, firstly, I would like to have a brief introduction about the Sigmatrix. This is a provider of the 3D tolerance analysis tools. So Sigmatrix has over 25 years of history. So in 1990, it is a sector in the TI, Texas Instrument, that is focusing on the numerical analysis method development for weapon system. And he has two core technologies. One is the statistical analysis method. The other one is precise constraint technology. Here we say the constraint, that it means assembly constraint. Okay, so in 1999, the Sigmatrix are formed in Texas, and 2009 7-8 system acquired the Sigmatrix. So from the 1999 to now, the Sigmatrix integrate 4 CAPE systems. The first one is PDC Creo and Dassault system, that is CATIA and SolidWorks, and also in 2017, that is NX. So there is an integration with those 4 CAD systems into the software. And now today, the 7-8 group continuously have an investment of more than 15 million US dollars to the Sigmatrix to the development and this TA tools. And he has over 1,000 customers in more than 40 countries that use these tools. Okay, so now this is a product portfolio of Sigmatrix. So today we will focus on the 3D TA tools. We call it CETOL 6 Sigma. So this is a 3D tools. And he also provides some basic tools like 1D TA tools. We call it CETOL. And also he is an expert of the GD&T. So he also developed another product called GD&T Advisor, but this is only for PDC Creo. It is an expert system. So, and also Sigmatrix provide these services, including the tolerance analysis training and also consulting services. So you can visit the website of Sigmatrix to get more detail about these products and services. So now I would like to let you know some of our customers who use the CETOL. So this slide shows you that in different industrial field. So you can see that the major industrial. There are many customers in the automotive and medical industrial. So this is also automotive suppliers. We got some consulting services for Tata. It is also related to the automotive industrial. The other industry field like defense, consumer, power system, HVAC. Okay, I'm stay in Taiwan. So in Taiwan, I can show you some our customer. He used the CETOL to do the torrent stick-up, like the EMS company, Foxconn, and Flextronics, and also Delta Group and Kimpo Group, and Delta Lion, and also Lion. Okay, here, as I know, there are some just a part of the customer in Southeast Asia. So like the key site in Malaysia and also Celestica and Dyna Optics in Singapore, Flex in Philippines. Okay, so let me have an introduction about the CETOL. That is a three-dimensional torrent stick-up. So this is a traditional method to do the torrent stick-up. So it is one-dimensional stick-up. So usually first we need to find the cross-section and build up the dimensional chain. Then just based on your detail drawing to enter each dimension to the spreadsheet, right? By manually. Then you've got, then you can derive some equation to calculate the worst case results. This one. So this is very traditional method to do the 1D stick-up. So what is the 3D stick-up? So firstly, you got the 3D model, cake model, right? So even in concept design, you got the functional critical functional assembly interface. It is also can use this tool to do the stick-up. But in that stage, we usually do the sensitivity analysis. So going to the second stage, you got some drawing or you have to do the tolerance design. So you have to determine the tolerance value. So the second step, you can use the GD&T or even the linear angular dimensions. And in CETOL, all the tolerances, that is annotations in the 3D model. Sometimes we'll call it model base definition, say MBD. So all those annotations in your 3D model can be imported to the CETOL 6 Sigma, that is into the tool. So that if you have any design change, it will be updated automatically in CETOL. And the third steps, you can base on your actual variation to determine which distribution of the manufacturing data should be analyzed in the CETOL. So in the design stage, I believe that you are based on the normal distribution. But in pilot round or mass production, you got the actual data. So you can represent those distribution in CETOL based on your manufacturing data. It is like the non-asymmetric distribution. We call it lambda distribution. Yeah. Then you will got the results. So in this result plots, you can see two results. shown on this plot. One is statistical result. The other one is worst case. But we just talk about a traditional method to do the 1D stick up. You also can do the statistical analysis by using the Monte Carlo method. But in CETOL, as I say, one of the core technology is his statistical analysis method. It used the math method, so it is quite fast. I will have some introduced later about that method. So where to make improvement? So you can do something like improvement like design for assembly, design for manufacturing, and also you can uh, do develop some like cost reduction plan, right? So you will know that how to loosen the tolerances value, or you can just remove some inspection dimensions. That is also helpful to the cost down, right? Okay, here is a table that can compare with the traditional method, say spreadsheet. So you can see that if you use the spreadsheet to do the stick up, you need to derive the equation manually. But in CETOL, you just need to select the geometry surface. Then the CETOL will based on the CAD model to create the the loop to do the tolerance analysis. And also, sometimes we will mistake the direction that is plus minus in your spreadsheet, right? But you still can get the result, but that is not right. But in CETOL, you don't worry about that. It is automatically to determine the factor. And also about the nominal, CAD nominal. So when you change the CAD nominals, you have to update it in the spreadsheet. But in CETOL, you don't worry about that. It is also updated automatic, just one click. And also the tolerance value, it is the same. So you can link to the CAD dimension tolerances. So when you change the tolerances in CETOL, it can be written back to the CAD model. And about accuracy, so no doubt based on the automatic method, you got more precise on the during the process and the results. And two-dimensional stick up, you also can use the spreadsheet to do that, but you have to consider some effect from the other direction, like the contribution to a from X direction to Y direction. But in CETOL, it is actual 3D tools, so it is automatic. And okay, about the fastener conditions, so you may consider like interference fit or clearance fit, even the transition fit. But in CETOL, it is automatic considered. So also it will advise you if you have some interferences in the fastener, you will get some message in this uh, tools. And manage multiple loops. So for 1D TA, you need to do you can do one TA at one time, right? So in CETOL, only single model, you can have multiple measurements. So that is very easy to control the side effect for each other. Communication. So all engineer used a single platform to do the tolerance analysis. So it is easy to communication between the different departments over even the different design teams. And also based on the standardized workflow, you can have everyone can easily to exchange the information and also keep the knowledge internally. Okay, this slide shows you some major advantage of the CETOL. So the first one is fast. So because the CETOL Six Sigma used a mathematical method to do the statistical analysis, so it is quite fast. So for example, this assembly, you see this is a reducer, harmonic reducer, including 48, almost 50 parts. So there got full conditions, full configuration to be analyzed, and for 8 measurements. So you can see the speed, the progressive bar. You can see that this is a real-time speed. So you can feel that speed, right? But if we use a Monte Carlo, it is impossible. It may take several hours to do such kind of analysis. And the second advantage, that is reliable. So you can see this ribbon. This is a user interface in CETOL Six Sigma. So based on the standardized workflow, say step 1, 2, 3, to do the tolerance analysis. And the third advantage, that is precise. So CETOL used the precise constraint technology. It is just like kinematic analysis. The only difference is that is calculating the assembly variation just within a range, small scale range. That is within the tolerances range. And also there is some additional value. Okay, so you can see the movie, the bird puzzle. You don't see any fastener, right? So for this one, two things are very critical. One is the part order, that is a symbol sequence. The other one is the constraint. That is which one is primary constraint, what is the secondary constraint, and third constraint. So the CETOL used the same concept. That is the DOF analysis, degree of freedom analysis on the background. So user can easily identify which part is still under constraint or it is over constraint. So you will got it will brings more ideas to you about the assembly parts with simplicity. So you can reduce the number of fastener on your parts to save the cost. Okay, this slide just show you some TA method. So that's the worst case, no different. All use the vertex analysis, right? But there are two different methods to do the statistical method in the commercial market. So the CETOL Six Sigma is the one used the system moment method. That is the mathematical method to do the statistical analysis for TA. So in brief, you can see that what is the system momentum method? In brief, it used the first moment to represent the mean value and the second moment to represent the variance. That is the square of the standard deviation. And use the third moment to represent the skewness, and fourth moment to represent the kurtosis. So use those 4 indexes. You can successfully to represent the statistical distribution. Even you can represent a normal distribution or a lambda distribution, even uniform distribution. So CETOL suppose 3 types of distribution. One is normal. The second one is lambda. That is non-normal distribution. The third one is uniform. Okay, let's talk about the assembly constraint. CETOL used the 6 degree of freedom to constrain the parts in your assembly. Then to do the DOF analysis, that degree of freedom analysis. So you can see that there are more than 250 types of this constraint. So you can build up a model that is very close to the reality. For example, okay, this is the 3D model. When you select 2 planar surfaces, it may bring a different physical constraint, maybe planar contact or line contact, even the point contact. So it will based on your design intents. So for a planar contact, you may need to care about the flatness, right? But for the line contact, you may just care about the straightness. But for point contact, you might be just care about the position of this point. So this is very important to use for the assembly constraints. And this is another case at pin inside a hole. So if the hole is long enough to support this shape, it could be a coaxial constraint. But if it is just a sheet metal, very thinner, so it's just like a concentric endpoint. So this is total difference assembly constraint. So we have to very careful to deal with such kind of constraint in your design. Okay, let's talk about accuracy. The kinematic accuracy in CETOL could be very precisely considered. For example, like a joint with clearance. So there's 2 parts. You can see the sleeve bearing and also the journal. It is clearance fit. So you can see, you know that there are 3 conditions, right? First one, that is contact on the different side, just like under a torque, external force. And this just tangent contact on one side, on single side, just like gravity, right? All parts under the gravity. And this is floating. If you just like aerodynamics, okay, we have some fluid bearing here, so it is random. So there are 3 different kind of conditions in those 2 parts. So in CETOL, you just need a single CAD model, and the CETOL can represent those 3 cases in single model. Then you can compare the radial clearance here, that is offset, and also the actual clearance and float here. So you will see that the different result for those 3 cases. So you can make a decision to see which one is to be improved or to be avoided. To have any problem. Right? Okay, so this is also another precise assembly constraint. So you will find some many over constraint in the real situation. So what is over constraint? Each over constraint will be a measurement, means that it could be analyzed. For example, there are 4 pins, 2 parts. So 4-pin 4 holes. So obviously, the first 1-pin hole and the second 1-pin hole already constrain those two parts, cannot be moved or rotated, right? So the third one and fourth could be the measurement. So we can measurement the clearance to make sure there's no interference or no impact on the location pin, say the first and second ones. Okay, what is not close? So you know that when you do the one-dimensional tolerance stick-up, you always try to find a closed loop dimensional chain, right? So in 3D dimension tolerances, it is the similar concept, but it is all automatically. In CETOL, it will, based on your assembly constraint, to automatically check the closed or not closed. For example, it will show you the status by the DOF analysis, show you, okay, 0 over constraint and 0 under constraint. So this is a well assembled product. But if it finds some problem like not closed, something like this one, it will show you not closed. So engineer will note that if there any risk of like the deformation in the future production. And another tools, as CETOL show you the model graph. Okay, so just like the dimensional chain, but the difference is it is a multi-loops dimensional chains in X, Y, and Z directions. So that include the translation and rotation in X, Y, Z direction. So you also can fill or hide object not in the first chain. So there is several measurements in this loop. Okay. So you can find filled object for each measurement. And I would like to introduce some critical feature that are also very useful in the 3D DA tools. The first one that is you can link the tolerances to the CATE model. So you can see that. So when you change the tolerances in the CATE system, then you can just, okay, this is input. You can input the annotation in 3D model. And you will see the green dot means that they have connection. So when you change the tolerances in CETOL from 0.1 to 0.2, it will be immediately updated in the CATE system. So the same thing is, this is two-way communication. So when you change the tolerance value in CATE system, it is also be updated in the CETOL. Okay, so this is a fully integrated with the CATE system. And the other one, because they use the math method to do the statistical analysis. So something like GDNT, it is also math, right? So it is very quickly to deal with such kind of material conditions. So when you use the material condition modifier like circle M, circle L, the CETOL Six Sigma can deal with very easily and quickly. So this is talking about maxima material condition and also maxima material boundary. So you can evaluate the impact of the existing dimensioning scheme. And also this is also very critical task during the product development. So this is sensitivity analysis. So when you use the CETOL, you can verify, okay, you can see the plot, okay. In the horizontal axis, that means the dimensional variable. The vertical axis means that the output, that is the measurement. For example, the center, okay. So you will know that when you change this dimension, so how many changes will be happened on this results, that is the center. You also can identify the behavior. It is linear or not linear. So if it is non-linear, it would be second order analysis. So you can choose, you have options. You can choose the second order approximation to do the tolerance analysis. Okay, this is picture case, and sometimes you may need it. Okay, so assume, but this is based on some assumptions. So you know the deformation mode. For example, it is bending mode. And also it is only can solve simple problem in this approximation method. For example, you control the length of the plate, right? You also control the width of this notch. So you try to know when you insert the plate into the notch, you would like to know the diffraction or the protrusion to the top surfaces. So you can use the CETOL to do such kind of simple analysis. And also, this is pipe, right? There's two rigid pipe, and also there is a flexible hose between them, and you try to measure some clearance somewhere. Okay, so you know that on your detail drawing, you always make the dimension, for example, the length for the flexible hose. But you would like to know when it installed in this assembly, so how the length, even the bending radius, will affect the gate. So you also can use this CETOL to do such kind of analysis. Okay, finally, usually would take a lot of that to do the paperwork, right? So in CETOL, there is a report generator. So you can generate the report just one click. You can export to the like Microsoft Word or any other editors, okay, like this one. So only a few minutes, you can generate the report. Okay, so why is the CETOL succeeding? So better products through mechanical variation management. So first, you can maximize the return on your MBD, MBE investment. So I know maybe just a few percentage of company they are leading to the MBD strategy, but you may still make the dimension on the 2D drawing, right? But as I know, there are about 30% of the company they already use the MBD, so they use a 3D PDF to release the drawing. Okay. So all the information are embedded on the 3D model data. The second one that is improve profitability by balancing the quality and the cost. So you know how to tighten or loosen the tolerance value to balance the manufacturing cost. And the third one, achieve faster time to market. So you can reduce the iteration number of the prototyping. The fourth, deliver more innovation products through better understanding of mechanical variation. So based on the workflow during the tolerance analysis, you will find that it is also the very good tools for design review. So you can do some review about the DFA, design for assembly, DFM, the design for manufacturing. And the last one, capture, transfer, and retain critical product and process knowledges for your company. Sorry. And also, the Sigmatrix has outstanding technical support. So all user can upgrade to new version every year. So because Sigmatrix will release new version based on the new CAD system. So almost every year you got a new version of the CETOL for your new CAD system. Also, all users can access the support website to see some valuable knowledge base article. And also, user can submit a ticket to the support center and got some technical support. So here's some feedback from our customers, like expert advice, quick response, and helpful information like that. Okay, when to use the CETOL, when to do the 3D dimensional 3D tolerance analysis. So you will see this is a general product development and design cycle. So concept design, detailed design, no doubt, right? So that's talk something about the prototype stage and pilot run or mass production stage. What we can do. Okay, in the prototyping or pre-pilot run stage, you can study some impact from the different process capability impact, so that you can make decision to how to define or specialize the SPC in your future production or for your supplier. So in the mass production, so you can do the tolerance audit for the optimizing the tolerance value. So you can you can make some tooling change, right, to get the result, have a better result without the shift to the mean value, right? So in that time, you can use the CETOL to do some adjustment or improvement on the tolerances, even the nominal, nominal. I should say mean value, manufacturing mean value. Nominal, that is specified on the drawing. Usually it is hard to change in this stage. Okay, where to apply the CETOL? I just showed you some cases at our customer site. So this is Porsche. They use the CETOL to analyze like the injector axis to the distance from the axis to the combustion chamber. Okay, that should be some performance issue. And also he analyzed the injector cone angle. Yeah. And this is just engine packaging, so you can see the engine room. So there's many clients you can use the this tool to do the analysis. So it is a typical 3-dimensional tolerance sticker, right? Okay, this is body white, so you can measure the gate, and also the flash, right, between the trunk and the lamp. Okay, this is door latch. This is very critical, right? So you can see that this is our customer. You can see the situation, the problem they met, that is up to 60 hours per design on simple stick up. But use this CETOL, they can save a lot of time and also save the prototyping iterations. So you can see the payback up to the 16,000 US dollars for product for single product, and they got 8 products per year. Okay, so totally they save 128,000 US dollars. We got a lot of customer. They provide the latch, yeah, for automotive, straight tech, and in America. Okay, this is parking gear. Okay, so you also save a lot of time to do the tolerance sticker. Make sure every gear interlock is in the right position. So you can see completed in less 1 day. Okay, originally spent over 2 weeks to do this tolerance analysis for this case. And this is analyze the clearance between the fan, the blade, and the shroud, the housing. So you can measure in different direction, like the vertical, horizontal. This is the gearbox. Okay. So the benefits saved a lot of time. Only spend 1/3 of the usual time to do this tolerances analysis for this company. It's a Volvo and Chrysler for powertrain. So it helps to solve some warranty issue and also the gear noise. Okay, this is engine. So this study saves some machining cost for the line boring for the liner, cylinder liner. It is very expensive. So they try to shorten the length of the liner. But the requirement is this ring, piston ring, cannot protrude to the top space of the liner. So it is very precise current sticker. So set up a lot of money. Okay, so this is automotive setting latch. Okay. And this is a braking system. So you can measure the gap between the disc and the brake pad, the caliper. Okay, this is very typical. Every automaker, engine maker, they have to do the tolerance pickup for those 2 clearance. That is the clearance between the piston and the valves, because it is impossible to inspection during production in the production line, right? So they have to do the tolerance analysis very reliable in the design stage. Okay, this is the front side, a sensory belt driving system. So they analyze the alignment between those pulleys, including the angular and also the offset misalignment. And this is a transmission, say CVT, continuously variable transmission. So high speed, low speed, two different configurations in single model. And the multiple measurements like angular misalignment and offset misalignment, also the twist. And this is motor drive. So it is very complex for the gear system, right? So you can measure the engagement and also make sure this is the outlooking appearance alignment of the housing, and also the parallelism between two shafts. So they are all typical three-dimensional turn stick-up. It is quite hard to do the stick-up by using the 1D stick-up method. This is lighting. Okay, so this is it is dynamic curve lighting. So there's two axis rotation for this light units. So you have to make sure the gapes, and also make sure the location and angle of the light source, and also the reflecting components, right? Okay, so this is interesting for manufacturing application. So this is already in mass production. You may have even first, second source supplier, right? So the goal is source separate to achieve product cost requirement. So after analyzing the stick-up, tolerance stick-up, we find that side plate have over 80% contribution to the final variation. So they focus on this part supplier. They got three supplier, say A, B, C, and they got a different manufacturing data, right? Different mean value and different distribution. That is different standard deviation. Of course, the unit price is different. So they use these tools to evaluate three suppliers based on their capabilities and qualities. So this is table compare the supplier A, B, C. So you got an equivalent to the total part cost here. Okay, the goal is reduce scrap and manage the supplier. Maybe it is benefit for outsourcing the other suppliers and increase the yield satisfactions. Okay, so in the last, I would like to play a video for you for more understanding about the operation environment in this software. Okay.
Sigmetrics, global experts in GD&T and mechanical variation, is proud to announce the release of CETOL 6 Sigma for NX. NX users are now able to benefit from the same powerful yet easy-to-use 3D tolerance analysis solution used for over 25 years by engineers worldwide to optimize their product designs. CETOL works directly with NX files. No conversion to CAD-neutral formats such as STEP or JT is required. To start a new analysis, simply select the NX assembly file to use. Opening a previously saved CETOL analysis file automatically opens the associated NX model. The hierarchical tree view, similar to the one used in NX, helps you easily understand the relationships between assemblies, parts, features, tolerances, variables, and assembly constraints. The graph view provides another perspective with a visual indication of the relationship between parts in the assembly or features on a part. Assembly states allow you to define completely different positions of the parts included in the analysis and even what parts are included. CETOL places them based on the assembly constraints you define within the tool, regardless of how they are placed in the NX assembly file. A single CETOL's data file can therefore include all the analysis you want to perform on your designs. When the model is complete, solve once. CETOL automatically calculates the worst case and statistical results with desired quality metrics of all distances and angles analyzed. It also simultaneously calculates the sensitivities and contributions, both presented in an ordered Pareto diagram from biggest to smallest. Sensitivities, along with a related visualization tool, help you understand how variation from a particular source impacts the atoms analyzed. Contributions let you know which particular sources of error are causing variation in the assembly level requirements being analyzed. These are the tolerances you should consider reducing to achieve the biggest improvement to your design. Changes to any of the tolerances or distributions on the input dimensions immediately update the results, allowing you to find the optimum set of tolerances for your design requirements very quickly. Competitive products require you to rerun the simulation when anything changes. Few people perform tolerance analyses daily or even weekly. CETOL therefore includes many forms of assistance to help users return to the software. The advisor provides guidance on the next steps or items that should be reviewed by the user. Context-sensitive help on any advisor message or CETOL window is just a click away. And throughout the help system are links to videos that help explain the concepts visually. When you're done with your work and need to communicate the results to others, CETOL offers a very flexible report generator that you can tailor to your needs. Whether it be a document format for archiving or a table showing the contributions of all variation sources to all requirements using color coding to highlight critical elements. For more information about CETOL Six Sigma for NX, please visit our website at sigmetrics.com.
Okay, so you just say the CETOL Six Sigma, that is for NX, but it is very similar for the other CAD system, like the Creo or CATIA, even the SolidWorks. But there is a bit of difference for the SolidWorks and CATIA legacy version. It is an add-in application in those two CAD systems. Okay, so for NX, that is standalone CETOL. But anyway, they are all use the native CAD file. You don't need to have any like conversion or any pre-processed to do for the CAD model. So when you have any design change, just one click you can update it automatically. Okay, so any questions?
Okay, thank you, Liang, for the presentation. To the audiences, if you have any questions, please feel free to type it into the Q&A panel, and we'll be happy to help. And while we are waiting for the questions, let me tell you that we'll send you a questionnaire after the event. And please fill in the questionnaire and you'll get the download link for the presentation file.
If you need more information, okay, two ways you can do. First one, visit the website of Sigmetrics, and also you can contact the sales, and we also can provide a demonstration, and even the if you have any cases interested, we will try to provide it for your reference.
Okay, I see there is no question here. So let's end here. And thank you for the presentation, Leon. And thanks to all the audiences. And we'll see you next time.
Okay, thank you all.
Thank
Thanks
you.
for your time.
Bye.